All right, hello again. Here we are, another problem. This is going to be, let me check to see, make sure the audio is working before I begin. All right, hello again. This is going to be path of maximum gold, medium LeetCode 1219. Let's get it going. So this one is going to be a new question now, different from, not a question I've already seen. The other one was a question I've already seen, and I, came up with a much faster solution than the first time around. In a gold mine grid of size m by n, each cell in this mine has an integer representing the amount of gold in that cell, 0 if it is empty. Return the maximum amount of gold you can collect under the conditions. Every time you are located in a cell, you will collect all the gold in that cell. From your position, you can walk one step to the left, right, up, or down. You can't visit the same cell more than once. Never visit a cell with 0. Hold on a second. All right, sorry about that. Minor interruption. All right, can't visit the same cell more than once. Never visit a cell with 0 gold. Never visit a cell with 0 gold. Oh, that's interesting. Okay, you can start and stop collecting gold from any position in the grid that has some gold. What? Start and stop at any position. From that position, I can't visit things that don't have gold. Once I reach a cell, I can't revisit that cell because I collect all the gold in that cell. Oh, that's a very interesting question. Path to get the maximum gold. Usually this is just some kind of like graph traversal type of question. Usually you can DP, modify the graph traversal, make it just a basic DP. Anything that's like grid based is usually not that hard for that reason. It's a pretty high submission rate, high acceptance rate, relatively. 25 cells containing gold. Oh, that's not a lot of cells. Okay. This probably could be brute force then, from all the starting positions. If the grid is only m by n, oh yeah, it's not. 15 squared is 225, 225? 150 plus 75 is 225. Yeah, 225 times 25 is not a lot. if you just started from every cell and then went through all of the possible sequences, I suppose. Yeah, okay. What's 25 times, let's say 25 times 200 would be like 2,500, would be like 50,000, right? And then excuse me, I think you get 25 times 225 would be like 25 times 200 plus 25 squared, which is kind of like 50 times 100, which is 50. Oh, is that right? Not 50,000, is that right? 200 times 25 is only 50 times 100, which is like 5,000. Yeah, it's actually like 5,625. That's not a lot at all. So this, you could do even more than that. You could probably multiply that by 15 again. You probably could do like quartic time with these numbers. So you could like probably like really brute force this. I'm not sure exactly how I want to do this then. It's a good question. I typically would want to do this faster, but it looks like I probably should do more brute force sort of solution because of the constraints, and I probably shouldn't waste too much time trying to find a faster way. Okay. How could this work? I I could try every starting point for starters. There's 15 squared starting. Actually, no, there's only 25 cells that contain gold, so there aren't that many starting points. And then from that starting point, I can try to find a path that gives me the most gold. Depth first search through all the possibilities. Yeah, it creates a tree actually of possibilities. Right, there's I could use some level of DP where I would say, starting from this point, I can go to some other point, and there's a maximum amount of gold I can get from that point, right? So all of the possible children I can go down. Let's go to Scaladraw. Let's try that out. I want so we've got 0, 0, 6, 0, 5, 8, 7, 0, 9, 0. Okay, what am I thinking here? I'm thinking from 6 I can go to 8. Only child I can go to. From 8 I can go to 5, 7, or 9. And then from each of these spots, these don't have any children. Now, I want to do some kind of DP type of a thing where I need a bigger test case actually. Like that's one test case, but this doesn't really help me that much because it's a little too simple. Let me try something that is a little more complicated. So I'm thinking, what are like some of the... Okay, 1, 2, 3, 4, 5. Oh, and this is this is not a square grid as well, to make things more complicated. Okay. Interesting. So 1, 2, 3, 4, 5, right? So if I start from 1, I can go to 2, 3, 2, 3, 4. I can go to this direction. And that's kind of it, starting from 1. The question that I have is like, what about things that where there's a cycle, right? It's kind of what I'm concerned about, because these examples actually aren't that great. These examples aren't that great. Deep breath, right? Deep breath. Like what about something... Okay. What about something that it's like a 16 by 16. Let's just do 2, 3, 1, 4, 4, 5, 2, 1, 3, 6, 8, 9, 1, 2, 5, 6. So what I'm concerned about is like, okay, let's say start at 5. I can go this way, but the problem is that I can go here and then here, right? I can go this direction, or I can go this direction. Or, you know, whatever. Maybe I should use a different color. And the reason this is interesting is that these are different. The state that you end up with is considerably different if I go around a 6 versus if I go around a 2. Like I can go 5 to 6 or I can go 5 to 6. And the reason why 5 to 6 is different is that I can go 5 to 6 to 8 to 2, right? And I don't necessarily want, because the state changes after each move, the state of the board changes after each move, I don't necessarily want to go all the way through. Like I don't necessarily, not all the way through. I don't necessarily want to get like the maximum amount of gold I can get getting to this point. Like I guess what I'm trying to say is I'm trying to think of a DP approach, but it doesn't really make sense because if I try to get to 2 with the most gold possible, starting from 5, excuse me, I mean, maybe I can go backwards from each beginning and end point. What's the most gold I can get going from this point to, you know, these intermediary points? Yeah, I don't know. Because maybe I could do it that way, get the most gold from this point to this point. I feel like I'd have to go something like that. A very long path. I don't know. Yeah, these other examples are a little bit like too simple. They don't really capture this kind of notion of like there could be a lot of different paths that you have to consider, a few different paths to consider. Okay, I don't have the answer to this immediately. Thinking some kind of DP solution. I think it's got to be some kind of DP solution. I don't think I'm gonna go lay down and think about this a little while longer. I don't think like a basic search is gonna be okay. Excuse me. Like a depth first search. I don't think a depth first search will be good. I don't think so. I could be wrong about that, but it's just you'd have to go through every possible path from A to B for every pair, A to B, A and B. And that's just, I think, too expensive. All right, there's a lot of possible paths. Excuse me. Okay. What could be done here? How could this be done? Hmm. Excuse me. I mean, a depth first search would give me the optimal path from a particular point. Excuse me, but that's not correct. It's not fast enough, actually. Can I even DP this though? Because it's too many. The state change is very dramatic, right? Like it's the change in state is every move changes the state of the board. So it's kind of a tricky thing here. Excuse me. Oh, maybe I could binary search. Binary search to see if there's some kind of path that gives me an amount that's. Well, I'm just trying to get the maximum amount every time, right? So it's not really. Um, 2 to the 25th different board states, right? If I add or remove the gold of a particular spot, 2 to the 25th is quite a lot. 2 to the 20th, I think it's 1 million. 32 million. It's a small number of board states. Actually, it's going to be less than that because I can't actually remove every. I can't actually remove every. What do you call it? Can't actually remove every gold cell in any particular order because the removals are consecutive. There really aren't that many possible board states. There could be differ from the original. Interesting. So I suppose a depth first search with memoization is probably the way to go, with an extra parameter for where the player currently is. So that would give me times the number of possible board states in all of the DFSs, which I don't think there are that many actually. I think it ends up being quartic time overall. And it's actually optimized a little bit because there's only so many states it could even start at. Only so many states it could start at, and only so many states that can even exist from each of those positions. So I don't think it's that bad. So I think in this case, I'm just going to use raw computation and memoization. Just be very direct. Just take a very direct approach, a relatively direct approach. Relatively straightforward, relatively direct. Don't try to think about it too hard. There's probably a way to do this a little bit better that involves dynamic programming, but I'm going to say I don't know that solution offhand, and I'm not going to try too hard to come up with it, to conjure that up. So I'm going to go with I'm going to go with use some memoization for this one. So I'm going to use a map of a pair and I'm going to use an integer key for the row and column as a single integer, and then I'm just going to have a vector events for the board state. So it's a pair of these things. So it's vector of vector. That's a pair of these things, and that's going to be map that to integers and use that to memoize. Const.o DFS. For each rows, grid.size, and columns. Grid of 0.size. Let's make sure these are always at least size 1. They are. Okay. DFS is going to take constant row, or no, key. Well, row is fine. Column. I'm going to say int I is 0, I is less than, or position. Well, I is fine. Total. Is less than total, plus I. The row is going to be I mod something or other. Column. Column is going to be I modulo the size of the row, which is the number of columns. And this is going to be, R is going to be I divided by the number of columns, divided by the size of the row. And I'm going to say DFS of row column DFS, return best equals standard max of best, and DFS. So the way this is going to work is if row is greater than or equal to 0 and row is less than number of rows, column is greater than or equal to 0 and column is less than number of columns. If that's not the case, that means that we're out of bounds, and we just return -1 or return 0. And then the key is going to be the row times the number of columns plus the columns. So this is going to be the size of the row times the row plus the columns. So if memo of key, these I think are also going to be optional. That doesn't need to be an optional, actually. Pointer is memo.find key. Oh, I see. We'll just say position, and then const auto key is going to be standard make pair of position, and there's going to be a state here. Standard vector state. So not sure about this one. The original state is just going to be grid. I think I create a new state each time. I think that's fine. I think that's okay. So make pair. And find the key. If pointer is not equal to memo.end, then return memo of key, or just pointer. Okay. So yeah, it gets a little bit more confusing. The state is going to be updated now. So I'm going to say gold, or there's a certain like current amount of gold, I think. As well, something like this. Current, or just amount. Current plus grid of RC, or state of RC, I should say state of RC. And then state of RC is 0. And then I do this loop, and I'm going to say return amount. Okay. For each direction, it's dr, dc, I is 0, I is less than 4. Each direction, we're going to go in, increment I, swap dr, dc, and I think dc multiply equals -1. So I'm going to the right, then I do a swap, negate, now I'm going down, swap, negate, I'm going to the left, swap, negate, I'm going up, swap, negate, I'm going to the right again. New row is row plus dr, new column is column plus dc. If, well, you could just take f of new row, new column, amount, state, and what's the next part? F. And I think I want the result to be the maximum. I don't do this too often, by the way, this like memoization, top-down recursion memoization, at least in this fashion. And then memoize on the key, or it's a new key, so it's again standard make pair of this position and the state. I think it's actually the same key. It's actually the same key. Memoize on that key. So very interesting. Yeah. I mean, I could try this. I don't know what this is going to give me exactly. I don't really know. Probably some mistakes in here too, things I didn't realize to think all the way through. Excuse me. Oh, this is if grid of RC is greater than 0. And oh, this is also if not this, or grid of RC is 0. We just return stop right there. What's this? Okay. So, oh, I don't have, I think this needs to be 0. No. It's something like this, a little more complicated, I think. I don't know. Pointer, this should be an int. Oh, I did that wrong. I see. Whoops. That's my mistake. Don't need that. I think I can do pointer second. Yeah, dereferencing the pointer will give me the runtime error. Okay. Stack Overflow. Of course. Interesting. Of course. So state. Shouldn't be grid, it should be state. That's also a mistake. That's a considerable mistake. Wrong answer. 0 should be 24. Also 0 should be 24. Oh, I know what's wrong. This is going to be this result plus, no. So, right, how do I get, when I pick up the gold, I think, I want to say it's something like the following. Let's say the amount is here. I'm going to take the result and I'm going to add to it the amount. So it's the maximum gold I can get from any particular direction. And I don't think I even need this, actually. Maybe I don't need that. Well, I didn't really think that one all the way through either. What does that do if I do it that way? I think that's what I want. Oh, there we go. Okay, great. Nice. Very good. What was my picture here? 2314. Whoops. 2314. 2314. 4521. 4521. And 3689. And 1256. Okay, let's try that one. See if I get the right answer doing this. And then I can test to see if it times out. Okay, 400 milliseconds. Okay. That's a lot. That's a lot of milliseconds. Quite frankly, that's quite a few milliseconds. Yeah, I don't know. Let me do 15. So 0, 0, 0, 0, 0. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I'm basically just going to copy paste this a few times just to see how much more expensive does this get if I do it this way. How much more difficult does this get if I do it this way? Okay, that's still reasonable. I could add a few elements here, like 10, 100, 1, 2, 3, 4, and 5. Let's see. Let's see. Okay, 900 milliseconds. Now let's make it more interesting. All right, let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. 1, 2, 3, 4, 5. Yeah, 15. All right, let's start removing some of these elements too. Because there aren't that many. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's already too many of these. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's kind of sparse. Maybe I should have picked a slightly different array. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, I'm just going to remove a bunch. 31, 30, 29, 28, 27, 26, and to 25. Okay, something like this. So very sparse. Hopefully, okay. So this, I'm missing, I did it wrong. Somehow I did this wrong. Okay, okay, despite there being so many cells, because these 25 are kind of far apart from each other, they don't interact very much. It's not really that big of a deal. What if they're all come like right on top of each other? It's kind of what I was hoping for. What if these are all just on top of each other in a 5x5? That's probably the most expensive I can make it. And then just everything else is empty. Excuse me. There we go. 10, 2, 1, 4, 5, 4, 3, 2, 1, 2, 12, 6, 8, or 9, 8, 2, 3. So we have 5, 1, 2, 3, 4, 5, and 100, right? 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is probably about as expensive as I can make it in terms of computation. I think if I can handle this test case, then I should be able to handle all the test cases in the group. Okay, that's not too bad. Looks like it's okay. So I think this is the correct answer. I'm going to try it. I'm a little bit scared, but we'll just see how it goes. Could be wrong. Could be time out. I don't know. Memory limit exceeded. Oh man. You don't see that every day. Really? Oh man. Memory limit exceeded. Whoa. What? Okay. It recreates the state at each step. I mean, the key kind of, I don't know. Whoa. I don't know if that helps if I do it like this. I don't know if it's still correct if I do it this way. So that's interesting. It was a memory limit, not the time limit. I was kind of expecting this not to work. Oh, that'll work now. Okay. Doesn't use as much memory if I do it this way. That's surprising. Okay. I don't know why that saves me on memory. It really shouldn't, but maybe it does. I don't know. All right. Let's go for it then. Let's try it. TLE. No. No. It's just too slow. Ah, that's unfortunate. Well, that sucks. No. Is it just this test case? It's TLE. Oops. Undo that. Actually, can't undo that. Shoot, I want to copy this. Yeah, I mean, it was just kind of close. It's kind of it's very, like, kind of a brute force sort of a thing going on here. It's a pretty, it's kind of tough. TLE. What if I don't do this? Is it still TLE on this one? Maybe it's going into a loop and I don't realize it. No, it's definitely. I think, I don't know if this will still be correct if I I don't know if this is still correct if I mess with this too much, but it doesn't look like I can speed it up. So yeah, okay, so it's a little too slow. I mean, you know, it's a lot faster if I do it this way, but it's not correct. Gotta restore this state. It's so slow. It's so slow. No. And if I just copy the state altogether, oh, just TLEs. Okay. Gee. Yeah. I don't know what to say here. This is a tough one for sure. It's too slow. Too slow. About this one. This one alone. This one alone is too slow. Darn. Darn. I need to be more clever here. How many submissions do I have here? Okay. Memory limit, time limit. Okay. Dang. Dang. Okay, well the idea works. That's good. It might be worthwhile to put some of these checks here. Actually, the way this is set up, it's worthwhile. Would save a significant amount of time to actually skip one jump here. One extra step here. It's worth doing. This will actually make the oh, RC, this is wrong. This will make the recursion tree to perform have one less level. Still timeout though. Shoot. Darn. Darn. I don't know what to say. That's unfortunate. That's unfortunate. I mean, I could hash these things together. It might make things faster. Hashing a vector though is pretty awkward. I mean, I can do it. It would probably make things faster because it wouldn't be, there's this extra logarithmic cost that's invoked each time I use the map. Like I said, I could try to go for a unordered map and write a hash. Excuse me for these pairs. That's not a bad idea. Maybe that's what I should do. It'll definitely use less memory. It's maybe a little bit awkward though. It's a very basic approach. I'm wondering if there's like a better way. There's probably a better way that's like just strictly dynamic programming that maybe uses like a few different variables. But I can't see it. This is just, I don't know, the way that I'm doing it here is just recursion with memoization. I was hoping it'd be fast enough. It can be done with a slightly different approach. I would guess this is probably not the approach they're looking for though. I would assume it's not. And the way this works is it's like a struct with, I forget exactly. It's like every time I do this, I have to look it up because it's kind of involved thing. Not the destructor. What did I click on? What did Anyway, I don't know. What? Hash. Yeah. Standard hash key. So the hash function has to be a it's actually a as an operator. Struct my hash, yeah, custom hash. Standalone function object. Basically a standalone function object. Oh no, wait. Okay. Custom hash. And I like to put these on the same line. So yeah, const test, it's going to be this thing. This thing. Object, quite frankly, object. And this is going to be h1 is object dot first, and that's going to be an int. h2. So we're going to do for each vector in the object, we're going to create update the hash. Start off with h1. It doesn't have to be a perfect hash, it just needs to be a reasonable hash. Current, and we're gonna say standard hash. So this is for each x and v. Calculate a hash of x, and then take this current and OR it with this hash bit shifted by some amount. And maybe this should be an integer I. Oh boy. Yeah. Some kind of a hash. Doesn't have to be too crazy, but just something. And how am I doing on time? An hour now? Okay. All right, something like this I could try. This is a little bit more complicated for sure. Compile error. Oh, this is objects. Second. Yeah. Doesn't have to be a perfect hash. Tealy, still Tealy, no. No. Does it Tealy on these things? I wonder. That sucks. That sucks. No. It's actually slower now. It's slower now. No. No. That sucks. Well, that's unfortunate. Thought maybe that would speed it up, but actually it made it slower. Significantly slower. Made this significantly slower. No. That's so unfortunate. Oh, you gotta be kidding me. That sucks. That sucks. No. It's so slow now. The other one was faster, I guess. Gee. Oh, looks like I'm gonna have to spend some time really thinking about this question. Just makes it. Look at that. Just makes it. It's a lot slower than before. So if I didn't have a hash function, I just went ahead and didn't do it this way. Isn't that so much easier just to use a map? So much easier to just use a map. It does all of these things in a much better time. Not much better. It's better, but not by much. All right. How am I doing? 1 hour. Okay. I think I need to think of a way to do this in a more clever, or take a more clever approach to this. No. Excuse me. I'm wondering if I should just use a really straightforward backtracking and just go with that. Part of me thinks I probably should. Just really simple backtracking type of solution. Just go through straight through every path. Just go through every path. Oh. Excuse me. Yeah, I suspect that maybe because I'm trying to memorize the paths, that I end up just visiting every path anyway. But not only do I visit every path, I also make a copy of the state, and it's kind of unnecessary. And I don't really save very much by memoizing. Maybe that's the issue. I suspect that's the problem. I think trying to memoize might actually be causing this to take longer than it should, which would be kind of ironic, but I could see that happening. I can see that. That would suck if that's the case. Excuse me. How about something like this? How about something like this? How many changes I had to make? All those commented lines are different refactoring, different changes to refactor this, to remove the state and the memoization. I don't think I need this anymore either. Don't need any of these things. No position, no key, all these things. Yeah, nothing of this. Let me just try on the simple cases first, see how far that gets. Do like the first one. Oh. Okay, 5. You kidding? Really? 5 milliseconds? Oh my goodness. Alright, slightly harder cases. I would be annoyed if that was all I needed to do. You gotta be kidding me. Are you kidding me? Is it that easy? No, come on. Oh my goodness. Of course. No. Why? Oh my. Of course. I'm like here for like an hour, and it's like, no, it's that easy. Like you shouldn't have tried to memorize. It would have just been done very quickly if you just went for it. You kidding me? What a joke! Oh my god, I can't believe this. I mean, I can believe it, but it's also like, sometimes that happens where it's like, no, it's just supposed to be like a very straightforward. It's just supposed to be a relatively straightforward brute force algorithm, and you're just making it harder than it needs to be. You're just making it harder than it needs to be. Of course. You know, sometimes I wonder. Well, okay. Great. Great. Like, I don't know. Alright. I mean, you submit this like 10 times or something. I don't know what to say. Just brute force. Just use brute force. Acknowledging the brute force. Sometimes that's all you need. Sometimes the only thing that works, or it seems to be the only thing that works. I shouldn't say it's the only thing. It just seems to be. This is it. This is it. This is it. As far as I'm solving this one. Yeah, I mean, I don't know. Sometimes it's just, what to say. Submitted a bunch of times, so I don't feel so bad about getting penalized for getting it wrong a few times. You gotta be kidding me. This is like, of course. Of course. Of course. You just needed to basically brute force it. That's kind of what this comes down to. Let's go through all the possibilities. Find the best one. Exhaustive search. This is a more or less an exhaustive search. Yeah, with a teeny bit of code to just, I mean, not really, not even. I would say like maybe there's some code to not back, but no, it's more or less an exhaustive search. Like that's it. That's all this is. That's all this solution is just an exhaustive search. Like, are you kidding me? Really? Like, apparently it's not one of the fastest approaches either. I guess there's other ways of doing this. I'm sure there's ways to optimize this to make it even faster. But that is like really disappointing from my perspective, from my end. I mean, I'm glad I got it. That's a good question. It's good to ask questions that throw you off, but it's definitely annoying for sure. Definitely pretty disappointing, kind of annoying. Not really getting much different values for runtimes. I mean, I got it right. At least I got it. The memoization turned out to just make things more expensive than it needs to be, which is like, I guess that could happen. Yeah, I don't know. I don't know what to say. All right, well, that's that one. Could have solved that a lot sooner too if I just thought about, hey, this probably is faster if you just do an exhaustive search, relatively straightforward exhaustive search. Okay, well, in that case, I'm gonna go ahead and stop there. If you like the video, give it a like and subscribe for more. Gee, boy. I don't feel very good about that because I definitely could have solved that in like 15 minutes if I knew that the exhaustive search would have been sufficient. I feel like in that situation, though, you're kind of guessing that it's going to be sufficient. I mean, it's a pretty high chance it would be enough because there's not a lot of, there aren't really that many different possible paths that you could take, quite frankly. Yeah, especially if only 25 of the elements are relevant. There aren't that many. Yeah, I'm trying to think of this, like how many different paths there could be. Not that many. Not that many. Not that many. I could have actually tested that. That's probably what I should have done is tested it directly. Just have a 5x5 and test to see how much time the direct approach takes, and then just code that. I should use that technique more often with online exams and assessments, because I failed an assessment for a company a while back. I was really annoyed because that would have been a really good job. I was so close, and basically it was a question similar to this one where like a brute force backtracking probably was the way to go. Exhaustive search was probably the way to go. Anyway, yeah, so hail victory, and thank you for watching. I will talk to you soon. Get out of here. I will get out of here. No kidding. Yeah, I don't know. I don't know what to say. It's like, dang. Dang. Okay. Well, on to the next thing. On to the next thing. I think I'm going to take a break after that for a little while. I don't know. I might start the stream on another question, or I might not. I'll have to. I think I'm just going to lay down for a bit. That was kind of disappointing, I suppose. I think I learned something though. I learned that I could just test to see if the brute force approach, the backtracking approach, is sufficient, right? Like in those scenarios, I should be able to test it, and I should just do that, and then I can just if it works, just go with that. All right.